All right, thank you for joining us today. And in this video, we are going to apply the limit definition and also check it by using the power rule, right? The idea of limit definition is like we are trying to differentiate the function. But when you use a limit definition, you can also use the normal rules of differentiation to check if your result is right, right? So let's jump right in. With limit definition, we know that limit as h is approaching 0 of f of x plus h minus f of x divided by what h, right? That is the f prime of x, which is equal to that. Now, the idea is that we cannot plug this one inside its function because when I plug the 0 here at the down becomes 0, and then we cannot simplify that. So what we are going to do is now we need to do it in a such a way that we can come and cancel the h out, right? So let's go through the limit definition. So I need f of x, but f of x is given. So what I need to look for is I need to look for f of x plus h. Now this is what I do. F of x, which is given here, I will make sure that since this my f of x, or this x here is in parentheses, I'll put all the x in this also in what parentheses. So I'm going to have something like minus 2 x squared plus 4x plus 6. I do this to help me to figure out when I'm looking for f of x plus h. So see what I'm going to do. F of x plus h is equal to, you see, I'm going to rewrite this the same thing, but what is it going to change? I have x here in the parentheses. That's why x is here in the parentheses, x here in the parentheses. So if I don't have the x here again, and I have x plus h, then this one should be s plus h. This one too should be s plus h. So I'm going to have minus 2x plus h squared plus 4x plus h plus 6. So you see that this and this are almost the same. The only thing is this is s plus h, this is s plus h, this is s plus h, this is s, this is s, this is s. So I try to put them in parentheses so that it will be easy for you to what? Write out the x plus h. So when I put in the parentheses this way, I will be able to do this. Good. Now what I need to do is, okay, I try to expand the function small and then see what I'm going to get. So this is the same as minus 2x plus h, x plus h, right? So this can be written as this. Then when I multiply this, I'm going to have plus 4x plus 4h plus 6. Then I'll expand this one. X plus h is x squared. X plus h will be xh, another xh plus h squared plus 4x plus 4h plus 6. Then when I simplify, I'm going to have minus 2 x squared plus 2x8 plus h squared plus 4x plus 4h plus 6. So I distributed x to h, which is giving this, and then h to x, h to h, which is also giving this. And then from here, I just added this one together. Then now I can multiply through the minus 2, which will be minus 2x squared minus 4xh minus 2h squared plus 4x plus 4h plus 6. Right. So can I cancel anything in here? No, x squared, no x squared, x8, no x8, so I can't cancel anything again. So now I have f of x plus h, I have f of x. But instead of putting everything here on this minus the whole of this, what I'm going to do is I want to look for this. I'm going to look for the whole of this. So what is f of x plus h minus f of x? So that now when I get this, which is the one on the top here, I just place the results that I'm going to get on the top, so that it will help me not to write the limit, writing everything plenty like that. So now this is equal to this. So I'm going to have minus 2x squared minus 4xh minus 2h squared plus 4x plus 4h plus 6 minus. So this is the minus here. Now when I write the minus, I'll put everything that I'm going to write in what? The parentheses. So I need to look for f of x. F of x is here. So I'm going to have minus 2x squared plus 4x plus 6. Then what happens? Minus 2x squared minus 4xh minus 2h squared plus 4x plus 4h plus 6 minus. So I'll distribute the minus 2. I'm going to have plus 2x squared minus 4x minus 6. So you will see that minus 6 and positive 6, 4x, 4x, 2x squared, 2x squared. So what we left is, we are going to be left with minus this minus 2h squared plus 4h. Now I have h here, I have h here, I have h here. I can factor it out. So I'm going to have h out minus 4x minus 2h plus 4. So when I factor h out here, it will be left with minus 4x. This is like 2 times 8 times 8. So when I factor 1h, it will be left with 2h. And then when I factor h out, this is what's going to be left. So this is equal to what is here. And this is what is here. So I can replace by this. So my f prime now will be equal to limit h is approaching 0. Now the whole of this is this. So I'm going to have h minus 4x minus 2h plus 4 divided by h. And then h will cancel the h. And I'm going to have limit h is approaching 0 minus 4x minus 2h plus 4. Then now I can plug in the 0. So I'm going to have minus 4x minus 2 times 0 plus 4. And we are going to have minus 4x plus 4. So this is what I'm going to get at the end of the day. Right. So let us confirm this using the power rule, right? Good. Let us confirm this using the power rule. So let's do the differentiation straight away and see if we are going to get the same function there. So we have f of x to be equal to minus 2x squared plus 4x plus 6. So based on the power rule, what will be f prime of x? So a constant multiplying x squared, so I'll maintain then I differentiate x squared, I'm going to have 2x plus I'll maintain the 4. When I differentiate x, I get 1. When I differentiate a constant, I get 0. So when I multiply, I'm going to have minus 4x plus 4. And we can see that this is the same as that. So you see the struggle. We need to go through all this, put them in here and get this. But when we do the power rule, you can get it right. But one thing that we need to note is if the question is asking us to use the limit definition, then if you use any other thing, you score 0, right? So unless the question is open, find the derivative, then you choose the one you want to use. But it's advisable if you know how to do this. So you see that there's 1, 2, and you've gotten the results. And this one I need to go through a lot before getting the final results. But this one is helpful when the question is asking us to use the limit definition, right? And we finish using the limit definition, then I just differentiate it to confirm if I've not, interchanged minus, or maybe I've not done anything wrong when I was going through the process, right? So yeah, that's what you are going to get for the first one. Now what I'm going to do is with this one, the same thing, I use the limit definition, then we confirm with using the power rule. So g prime of x will be equal to limit h is approaching 0, f of x plus h, sorry, this is g of x plus h minus gen of x divided by h. We know gen of x to be equal to 4 over x, right? So as I said, I like to put them into parentheses. So x is in the parentheses, this one too is in also parentheses. Which one will help me to find gen of x plus h, which will be equal to, so I'll just interchange the one in the parentheses to x plus h. So I'm going to have 4 divided by x plus h in the parentheses, right? So as I said, instead of putting gen of x plus h, which is this, on top here minus this, I'll just pick 1 on the top here and then simplify. Then I'll just come and put the results there. So what will be gen of x plus h minus gen of x? Now gen of x plus h is this, which is 4 divided by x plus h minus, now what is gen of x? Gen of x is x over 4 over x. Then how to find how to simplify a fraction? My strategy, don't forget, first, second, third. So if we have this thing here, you should be able to do the fraction. So this is the idea. The idea here is that first, this is the first, right? So first means that this goes with this. So first, so 4 times x will be 4x. Second, second is this side. So this will multiply this one here. And this one you can use to do any fraction, any of them, any fraction is going to work out. Then minus 4x plus h. So first, this times this, second, this times this, then third. So third, you see that the third goes horizontally. So horizontally means that we need to divide and multiply the denominator, right? So divided by, so third, this and that. I'm going straight. So I'm going to have x plus 8x. That's so nice. So let's try and simplify. 4x minus 4x minus 4h. So I distribute the negative 4 to this and that. So divided by this one, I can write this as x plus this. And then, fortunate for us, this will cancel this. So we are going to have minus 4h divided by x plus h. Good. So now this is the whole of this. So we can place it here. So we can place this one here. So what will be the limit? The limit will be limit h is approaching 0. Then we place the whole of this on the top there. So we are going to have minus 4h divided by x plus h. Now you see that everything here which is equal to this is the one on the top. So I need to divide this one by h. But instead of dividing it by h, I'm going to use divided by h. Is that right? Good. So that's what I'm going to do. Divided by 8 from there. Right? So I'm going to have limit h is approaching 0 minus 4 divided by x plus h. X is here times, so don't forget this is divided by 1, like this is divided by 1. So when I change it to multiplication, this one will be 1 over h. Then now we can see that this h will cancel this h here. So we are going to have limit h is approaching infinity 0 minus 4 divided by x plus h. Then now I can plug in the 0 because now I don't have h, multiplying the function alone on the denominator, which will make the function 0. So this one will be minus 4 divided by x plus 0, and this will be minus 4 divided by x time, and this will be minus 4 divided by x squared. So that will be the result, minus 4 divided by x squared. So let's confirm the results. Let's confirm the results. Now if I have gen of x, which is equal to 4 over x, so we want to confirm this result here, right? So we know that this is the same as 4x to the power minus 1, right? So let's use the power rule. J prime of x will be equal to, I have my 4, so the 4 will be there. Now I need to differentiate x to the power minus 1. So minus 1 drop times x minus 1, then I subtract 1. So this one will be 4 times minus 1 will be minus 4. Then minus 1 will be minus 2. And this is the same as minus 4 divided by x to the power 2, which is the same as this. So we can use the limit definition and we can differentiate it to confirm, right? So as I said, if the question is saying use the limit definition, when you are done, then you do the normal differentiation to check if your result is true, right? Good. So that is the idea. But the rest I'm just going to use. Okay, so let me use the limit definition for this one too, so that you will know how to also use limit definition for this. Okay, so now the same idea, limit definition, limit. So what I'm going to do is I'm going to let f of x to be equal to 6 root of x, so that I can use the limit definition. So here will be f of x plus h minus f of x divided by h. So my f of x is equal to 6 root of x. So what will be f of x plus h? This will be 6 root of what? X plus h. Nice. So now I need f of x plus h minus this, right? So it's going to be f of x plus h minus f of x, which is equal to 6 root of x plus h minus 6 root of x. Now with this one, we cannot do any simplification. Can we simplify this? Yes, we can simplify this. Somebody is like, how? Yes. Look at how I'm going to simplify this. Now I'm going to simplify this by doing this. Now I'm going to simplify this. I'm going to write this one as 6 root of x plus h minus 6 root of x times. So I want to multiply this one by 1, right? But not just 1, but changing the sign here to positive. So I'm going to multiply this one by 6 root of x plus h plus 6 root of x divided by 6 root of x plus h plus 6 root of x. So this one will cancel this. So I actually multiply this one by 1, which is the same as this, right? Don't forget this is like divided by 1. So this will multiply this, and the top here too will multiply the top here. So let's go. 6 times 6 is 36. Then root of x plus h. Root of x plus h is just x plus h. Now look at something here, because this one is negative and this one is positive. When I multiply this one by this and multiply this one by this, they are going to cancel out. So they will go to 0. So with something like whenever you have root and you find a conjugate, or you want to rationalize it, and then you do the rationalization, what you need to do is you just multiply this by this and this by this. Remember, it's when you have the radical and you are doing rationalization, that's when you can do what I'm trying to say. Because when you multiply this to this, if you multiply this one to this and this one to this, they will cancel out. So I'm just going to multiply this by this. So I'm going to have minus 36, then root x times x is x divided by 6 root of x plus h, good, plus 6 root of x. So let's expand what we have there. That top will be 36x plus 36h minus 36x divided by 6 root of x plus h plus 6 root of x. So good. This will cancel this. So we are going to have 36h divided by 6 root of x plus h plus 6 root of what? X. Good. So now this here on the top, right? This thing on the top here is equal to what we had here, right? So what we are going to do is now, sorry, this is supposed to be f prime of x, which will be equal to this. So now f prime of x will be equal to limit h is approaching 0. Now the one on the top there is equal to this. So I'm going to write 36h divided by 6 root of x plus h plus 6 root of x. Now this that we have here is on the top. So I'm going to divide this one by h. But instead of doing divided by h, I'll do it divided by h. So I'm going to do divided by h. So that this one will be limit h is approaching 0, 36h divided by 6x plus h plus 6 root of x times 1 divided by h. Then this guy will cancel this guy. Good. So now I'm going to have limit h is approaching 0, 36 divided by 6 root of x plus h plus 6 root of x. Then now when I plug in the 0, nothing happens. So I'm going to have 36 divided by 6 x plus 0 plus 6. This one will be this. So I'm going to have 36 divided by 6 root x plus 6 root x. This will be 36. Then 6 plus 6 will be 12. So I'm going to have 12 root of x. And then 12 goes to 36. How many times? 3. Right? So I'm going to have 3 root of what? X. This will be the final results for this function right here. Let's confirm. Let us confirm. Y is equal to 6 root of x. Now we know that we can write this one as 6 x to the power 1 over 2. So what will be y prime? Y prime will be equal to, using the power rule, I have my 6 in front. So using the power rule for x to the power half, 1 half drops down. Then I have 1 half minus 1. So I'm going to have 6. So I think 6 times half will be 3. Then this one will be half minus 1 is minus half. And this is the same as 3 divided by 1 half. And this is the same as 3 root of x, which is also the same as what we've got in here. So we can, after we are done with the limit definition, we can also use this one to also solve this question as well. Right. I hope you got it. Now let's look at our second question. Second question, we want to look at the equation of the tangent line. So what is the equation of the tangent line? Y minus y1 is equal to mx minus x1. So anytime they give us x, this x which is equal to 3 is our x1. So here x1 is equal to 3. Right? Good. And then when we plug x1 inside this function, or when we plug x inside this function, it gives us what? Y1. So what will be y1? y1 will be equal to, when I plug this inside this, so I'm going to have 3 to the power 4 plus 2 times 3 minus 6. So what is 3 to the power 4? 81, right? Yeah. Plus 6 minus 6, which will be 81. So y1 is 81, x1 is what? 3. So I can write this one as y minus 81, which is equal to mx minus 3. So now what I just need from this equation is I need the m. Don't forget, m is the slope, which is the derivative, right? So we need to find the derivative of this and plug in x is equal to 3. then we get our slope. So what will be y prime? Using the power rule, we are going to have 4x to the power 3 plus 2. Then we need to plug in what? 1 to see what you are going to get. So plug in 1, we are going to have, so this one will be the m, 4 to the power, no, not plug in 1, plug in 3, 3 plus 2, and this is going to give us 3 to the power 3 is 27 plus 2, then 27 times 4, 7 4 7 4 28, 2 here, this is 4 2 8, so this one will be like 10 102, I'm sure. So this, sorry, 108, so 108 plus 2, which is going to be 110. So that will be the m. So with that, now we can plug in our m. So we are going to have y1 is equal to, sorry, y minus 81 is equal to 110 x minus 3. So this is what is called the equation of the tangent. So this will be the equation of the tangent line. Good. Now the next question is, find the derivative of each of the following function. So now let's go through. Now we are not using the limit definition again, so we just use the power rule to go through the process, right? So what will be f prime of x? Using the power rule, there is 2 here, which is multiplying the function, so we just factor it out. Then the idea is that now we need to differentiate x to the power 4, which is going to give us 4x to the power 3, right? Then minus, we have 5, which is also multiplying the x to the power 3. We factor it out and we concentrate on x to the power 3. So that one will give us 3x squared. Plus we have 1 over 3 multiplying x squared. So you factor 1 over 3 out, then you differentiate x squared, which is 2x. Minus, we have 7 multiplying x. So you factor 7 out and differentiate x, and we get 1. Then when you differentiate 12, you get 0 because it's a constant. So this is supposed to give us 8x to the power 3 minus 15x squared plus 2 on 3x minus 7. So this will be the derivative for the first one. Now this one, for us to differentiate, we need to simplify it, right? So this one can be written as minus 3 over 4 times 1 over x to the power 5, right? So when I multiply it back, I'll get this. So minus 3 times 1 is minus 3, then 4 times x to the power 5 is that. So that I can rewrite this one as minus 3 over 4 x to the power minus 5, right? So what will be g prime of x? Using the power rule, I maintain what is in front of the function 3 over 4. Then I use the power rule to differentiate x to the power negative 5. So minus 5x minus 5 minus 1. So this will be, when I multiply, I'll have 15 over 4 x to the power minus 6. So if I want to leave it this form, that's all. But if I want to simplify again, then I can write this one as 15 divided by 4 times 1 over x to the power 6, which is the same as 15 4x to the power 6 at the end of the day, right? So that's what you are going to get at the end of the day. And let's look at C. Now C, the same thing. So C here, what we can do is, actually we can simplify this. So x to the power 3 divided by t minus t divided by t. So this is like, this t here, t to the power 3 here is like t times t times t, which is divided by t. So 1 t will cancel t, which will be left with t times t, which is t squared. Then t over t is 1. So now you see that now our h of t is t squared minus 1 after the simplification. So h prime of t will be equal to, using the power rule, we are going to have 2t. When I differentiate, negative 1 is constant, so I'll get 0. Now let's look at this here. What will be y prime? This one, Y prime is just 0. Why? Because pi is a constant function and e to the power 3 too is a constant function. So when I multiply a constant by a constant, I get a constant. So when I differentiate a constant, I'll get 0. So that one was very straightforward from there. Now for me to differentiate s of t, I need to make sure I do some small simplification here. So this is the same as 6 t to the power 1 over 2. Please note the difference between 6 root of t and sit root of t, right? Because mostly some of you, instead of writing this in this, you rather write it in like t to the power 1/6, which is not true. The t to the power 1/6 is for this, because this is the sit root of t. But if you see that, look at this, you see that the if it was supposed to be 6 root, you see that the 6 will be up here. Good. So note the difference. Then minus t to the power 1 over 3 plus 9. So what will be s prime of t? Using the power rule, 6 is constant here, so I maintain it out. Using the power rule on t to the power half, half drops down, then half minus 1, which will be minus 1 over 2. Close the bracket. Minus 1 over 3 drops down, then 1 over 3 minus 1 will be minus 2 over 3. And when I differentiate it, then I get 0. So this is going to give us 3 t to the power minus 1 over 2, then minus 1 over 3 t minus 2 over 3. So that's what we are going to get for E. Let's look at F. Now this is the same as 2 over 7 times 1 over root t, right? Plus 3 times 1 over t squared. I just simplify it so that you will know how to go through those process. So when I multiply 1 to 2, I'll have 2. 7 to root 7, I'll have this. When I multiply 1 to this, I'll have this. Then this is like over 1. When I multiply, I have this. So this one can be written as 2 over 7 times root t is the same as t to the power 1 over 2, then plus 3 t minus 2. So I can write this as this. So that now I can simplify and write something like 2 over 7 t to the power minus 1 over 2 plus. So that now I can use the power rule. So I need to do some simplification before I go through the process. I actually do all those things because so that you don't get confused. But you can just move from here to here if you can see it straight away, right? So Vn prime of t now will be equal to, I have 2 over 7, what is a constant, multiplying t to the power minus half. So now I apply the power rule, minus 1 over 2 down, then minus 1 over 2 minus 1. Close the bracket, plus 3 out, minus 2 down, minus 2 minus 1. So I'm going to have, now this 2 here will cancel this 2. So I'm going to have minus 1 over 7 e to the power. Now minus 1 over 2 minus 1 is going to give us t to the power minus 3 on 2 plus, so minus 2 times minus 2 will be 6 e to the power, t to the power minus 3. So this is what you are going to get at the end of the day if you don't want to simplify again, right? So let's look at some, we are almost done. Let's look at this one here. It said explain why we cannot use the power rule on this function. So we want to look at the reason why we cannot use only, I would say only the power rule, right? So we cannot use the power rule because when we started the power rule, we made mention of like if a function is of the form x to the power n, right? And this function here, even if I put it into parentheses, I'll have x to the power n. And you can see that the function, when I differentiate the one in the bracket here, I'll get 1. But when I differentiate this one, I'm not going to get 1. So we can say that we cannot use the power rule because it's not in the form this, right? We cannot use the power rule because it's not in the form of this. Good. So that will be the implication there. Then perform some algebra to rewrite the function so that we can use the power rule on the new form. So now since we have y is equal to 2x plus 3 squared, when we perform some algebra, we are going to have 2x plus 3, 2x plus 3. Then we can expand. 2x times 2x will be 4x squared. 2x plus 2x times 3 will be 6x. 3 times 2x will be 6x. 3 times 2 will be 9. So this will be 4x squared plus 12x plus 9. And then now we can apply the power rule now. So the power rule here, 4 out. When I differentiate x squared, I'm going to have 2x. 12 out. When I differentiate x, I'm going to get 1. When I differentiate constant, I get 0. So this one will be 8x plus 12 at the end of the day. So that is how you can also perform. You can just perform this one so that we can use the power rule to go through the process. So with question 5, just factor the following polynomials. So you just need to just look for the factors of this and you can drop them in the comment section. All right. See you in the next video.